Okay, I think we are recording. All right, so I'm going to work through an answer here for this problem that was part of our first homework quiz, and it says, suppose that a medical test has a 92% chance of detecting a disease if the person has it, okay, and we call this 92% sensitivity, and a 94% chance of correctly indicating that the disease is absent if the person really does not have the disease, okay, and that's the specificity. And suppose 10% of the population has the disease, and the question that you were supposed to answer is B, whereas you're going to have to answer part A to get to your answer in part B. Okay, so I'm going to draw a tree here, and we are going to say either someone has the disease or they do not. So we're going to write disease versus no disease. And we say, suppose 10% of the population has the disease. So I'm going to put 10% here, 90% here. And then from there, the person can either test positive, okay, or they will test negative. Positive and negative also, okay? And so ideally, if they have the disease, they test positive. And if they have the disease, they're going to test positive 92% of the time, which means 8% of the time they will test negative. And on the other hand, if they have no disease, we expect them to test negative. And it says 94% chance of correctly indicating that the disease is absent. So we're going to put 0.94 here, which means 6% of those who don't have the disease will be flagged as a false positive, okay? And it says, suppose that a randomly chosen person does test positive. What's the probability that this person has the disease? So the answer we are going for is, what is the probability of someone having the disease given the person tests positive? And the way this is going to be calculated is that the numerator is going to be basically going to be disease and positive divided by the probability of getting a positive test. The numerator is further, this disease and positive is going to be probability of disease times the probability of positive given disease. So that's how we're going to get the numerator. And then this probability of positive, we're going to have to basically find these values here, okay? So this probability of positive is going to be 0.10. This is probability of disease times the probability of positive given disease. So 0.10 times 0.92. And this is going to be 0.092. This is probability of disease and positive. Okay, that's going to be part of our positive answer.
One sec to catch up, please.
Sure.
Positive. You've got the disease. Okay, so the 0.10 is for the 10% that really have the disease.
Yes.
That they tested positive for it is the 0.92.
Yeah, if they have the disease, it says if they have the disease, there's a 92% chance of detecting it. So we're going to get test positive 92% of the time.
Okay, and so when you multiply those two together, you get 0.092, and underneath it that says that is our P
of disease and positive.
Okay.
Disease and positive. Okay, and then there's a second way of testing positive. These would be the false positives. The person doesn't have the disease. That's a 90% probability that they don't have the disease. And yet, because tests are not perfect, they might still test positive, okay? And so this is going to end up being 0.054. This is probability of, I'm going to just write no disease times probability of testing positive given no disease. All right, and so this value is probability of no disease and a positive test. Okay, so we're going to add these two together to get the probability of positive. So the probability of positive, which would be the answer to A, is going to be 0.092 plus 0.054. Okay, and if I add these two together, 0.092 plus 0.054, I get 0.146. So this is going to be the value that goes into my denominator. Okay, and then the numerator up here, we've actually already calculated probability of disease times probability of positive given disease is 0.092. So the answer of probability of disease given positive, given these values, is going to be 0.092 divided by 0.146. And when you do 0.092 divided by 0.146, we're going to get 0.63. Okay, 0.63. And that's going to be the answer to that problem there. Okay, so I'm going to go ahead and stop the recording.